Our project is study of influence of KONGU tree sawdust on removal of fluoride in aqueous solution. Our project members are Mr. Deepak S, Mr. Arivasan R, Mr. Hemant Balakumar B, Mr. Varun Balakumar R. Our project guide is Mr. R. Anand, Assistant Professor, Civil Department, Bale High Tech Engineering College. Aim of this project is to remove fluoride in aqueous solution using KONGU tree sawdust. The main objective of this project is to design and select various parameters like bed height of the sawdust, particle size of the sawdust, concentration of the fluoride, and density of the compacted sawdust to achieve maximum efficiency for removal of fluoride. Optimize selective parameter by using DOE approach, that is design of experiments approach of Takeuchi method. Next, to attain maximum efficiency of various selective parameters in removal of fluoride. Next is to compare the results obtained from the parameter. And finally, to check the percentage influence of each parameter towards removal of fluoride. We have gone through many journal papers to attain basic knowledge on adsorption study by sawdust, defluoridation, column absorption study, and Takeuchi method of DOE approach. First paper is based on sawdust. Removal of cadmium-2 ion from wastewater by adsorption onto polyaniline coated sawdust. Next is based on fluoride removal. Removal of fluoride ion from aqueous solution at low pH using squaranamide. The third, review of fluoride removal from drinking water. Fourth, it is based on column absorption study, continuous fixed bed column study and adsorption modeling, removal of cadmium-2 and lead-2 ions in aqueous solution by dead catalysis cells. Next, continuous adsorption of lead-2 and methylene blue by engineered graphic oxide coated sand fixed bed column. The next is based on the Takeuchi method. Application of Takeuchi method in optimization of wastewater treatment using spiral wound reverse osmosis elements. Works done in this project: collection of KONGU tree sawdust, preparation of fluoride solution, batch study to determine the optimum pH that favors the removal of fluoride. Batch study is done as jar apparatus test. Next is the preparation of column absorption setup and run the experimental run and collection of sample. Next, to test the fluoride in the treated water. Then last, optimum parameter for maximum removal of fluoride. Adsorbent is the medium which adsorbs adsorbate on its surface. It is a surface phenomenon. In this adsorption study, sawdust is taken as adsorbent and fluoride is taken as adsorbate. The sawdust, which is commonly known as KONGU tree, botanically named as Hopea parviflora, it has an ecological characteristics of common emergent to canopy in evergreen forest up to 900 meter. It is mostly distributed in Western Ghats, South and Central Scientias. This is the sieve analysis tabulation of sawdust. We have bought raw wood of KONGU tree and we have grinded it using the lathe machine. Then we have sieved and we have weighted and it is tabulated. This is the pictures of dry, washed and oven dried sawdust. Preparation of fluoride solution. Fluoride solution is prepared by dissolving NaF, that is sodium fluoride salt, in distilled water. 41.99 gram of sodium fluoride gives 18.9984 gram of fluoride per liter. Then by interpolation it can be calculated. 8.84 milligram of NaF per liter gives 3.99, that is approximately 4 milligram of fluoride per liter. Similarly, 11.05, 13.26, 15.48 milligram of NaF gives 5, 6 and 7 milligram of fluoride per liter respectively. The next work done in this project was batch study. To obtain the maximum removal that favors by the pH, that is optimum pH that favors the removal of fluoride. In this batch study, jar apparatus test was carried out with 4 different pH values in 4000 ml jars with 25 gram of sawdust. Concentration of fluoride in each jar was maintained as 4 mg per liter. pH in jar 1 was maintained as 5, in jar 2 as 6, in jar 3 as 7, and in jar 4 as 8. From the batch study, it was found that optimum pH that favors the removal of fluoride was pH 6. Column absorption test is carried out with selective parameters and levels as tabulated. The parameters were bed height, particle size, concentration of fluoride, density of packed sawdust. The 4 levels of each parameter is in tabulation. Column absorption study was carried out on the basis of Takeuchi method design of experiment approach. For parameters of 4 and 4 levels in Takeuchi method, orthogonal L16 array is being used as shown outside. For 4 parameters of bed height, particle size of sawdust, concentration of the fluoride, and density of the sawdust packed with 4 levels, Takeuchi orthogonal array table is generated and it is shown in this slide. This is a schematic diagram of our experimental setup. This is the actual setup made in our environmental laboratory. It has one submersible pump, a column that is an acrylic pipe, 3 external filters, one RO booster pump to induce the vacuum, then 2 barrels to store fluoride solution. In each fluoride solution, pH is maintained at 6. Pictures of each run and with their parameters is shown aside. Test for fluoride in treated water. Fluoride is determined by titration process, which is one of the method adopted by the framed laboratory of Methoda department, that is Alpha Laboratory in Kilpa. The titration procedure is explained. Titration 1, NaOH versus oxalic acid. In this, the normality of oxalic acid has been determined. Titration 3, NaOH versus distilled water. In this, distilled water, 19 ml of distilled water in plus 1 ml of concentrated hydrochloric acid is titrated against NaOH. In this, normality of distilled water is being achieved. The titration tables of each titration has been displayed. Titration 1, NaOH versus oxalic acid gives the normality of the NaOH. Titration 3, NaOH versus distilled water gives the normality of the distilled water. Titration 2, NaOH versus sample water, that is the treated water, gives the normality of the treated water. Titration calculation for amount of fluoride A, that is titration 2 minus titration 3, that can be volume of NaOH consumed by titration 2 minus volume of NaOH consumed by in the titration 3 into normality of NaOH into normality of sample divided by volume of sample. By this calculation, we achieve amount of fluoride per milligram per liter. The titration values for different contact time for 16 runs, total 16 runs is been in slide. The concentration of fluoride with respect to titration. For 16 runs, 16 for each and every run, 4 samples, 4 contact times have been selected. The red the red boards shows that the concentration of fluoride. The percentage graph of removal of fluoride is in display. Signal to noise ratio calculation. Signal to noise ratio is a measure used in science and engineering to compare the level of desired signal and level of background noise. In this project, level refers to the signal, parameters refers to the noise. It is defined as the ratio of signal power to noise power. Signal to noise ratio can be calculated by the following 4 steps. First, to note down the given observations. Second step, to find out the mean of the data. Then third, to calculate the standard deviation using the formula. Then fourth, signal to noise ratio, that is mu divided by sigma. Signal to noise ratio of each and every parameter, accordingly it is in this table. Signal to noise ratio for the parameter bed height for 4 levels, signal to noise ratio for parameter particle size for the 4 levels, signal to noise ratio for the concentration of fluoride for the 4 levels, signal to noise ratio for the percentage of compaction for the 4 levels. In each and every level, in each and every parameter, each level has a maximum signal to noise ratio. From the maximum signal to noise ratio, bed height has its maximum signal to noise ratio of 12.7028 at the level of 3. Particle size has the maximum signal to noise ratio at the level of 3. Concentration of fluoride has the maximum signal to noise ratio at the level 3. Percentage of compaction has the maximum signal to noise ratio at the level 2. Thus, from the signal to noise ratio, control run that have to be run is 45 cm bed height, 500 to 300 microns of particle size, 6 mg per liter of concentration of fluid, and 10% compaction of sawdust. Thus, this is the picture of control run that have been carried out, and the parameters and their values are shown aside. The result of the control run. Maximum efficiency in removal of fluoride is attained as 98.77% at the contact time of 60 minutes in this control run. The influencing parameter in the removal of fluoride. Removal of fluoride has been influenced mostly by the particle size with the percentage of 40.61%, rather than other parameters like concentration of fluoride influences up to 23.54% and density of the packed sawdust influences up to 21.55%, whereas at least the bed height of the sawdust has 14.30% influence. Result and conclusion. Thus, from the above experimental project, we have achieved about 99%, that is nearly 98.77% of removal from aqueous fluoride solution using KONGU tree sawdust. This project can be continued with modified KONGU tree sawdust, that is activated carbonate, and other studies in sawdust functional group and surface area of sawdust after absorption. Thank you.